So now we have this question number 5, and it says determine if the following integral converges or diverges. Justify your answer, and we have a hint. It says use the comparison theorem in integrals. So yeah, we're going to use comparison theorem, and first of all, let's go ahead and write our function. So we have x squared plus sine squared x, and it's over x to the power of 5. First of all, we can go ahead and let's rewrite this as x squared over x to the power of 5 plus sine squared x over x to the power of 5. And so we know that x squared over x to the power of 5, that cancels out, that leaves us with 1 over x cubed. So that is equal to 1 over x cubed plus sine squared x over x to the power of 5. So we need to find, the way comparison theorem works is we have a function, and what we want to do is we want to find a function that is greater. And if we know that the function that is greater converges, then we know that the function that's smaller, we'll be able to determine that the function that's smaller will also converge. What does it converge to? This test has nothing to do with that. We don't know what it converges to. But what we do know is that it converges. And that's all we want to find out in this question. We just want to know whether or not it converges. So we know that sine squared x, this is bounded to 1. Because as we know, a sine curve, the max value is 1 and the min value is 1. So it's bounded to 1. So we can then rewrite this as 1 over x cubed plus 1 over x to the power of 5. And so this function is greater than equal to the function that we have originally. And so now we can do our p test. So we know that our p here is equal to 3, which is greater than 1. This means that it is convergent. And we are adding this to this, where p is equal to 5, which is also greater than 1. Therefore, it is convergent. And so if we have two sides of this that are convergent, convergent plus convergent means that overall it is convergent. And so therefore we can say that this integral, so therefore this integral is convergent. By comparison theorem.